So I broke section 3.2 up into 3 sections because it was just too long and there were natural breaking points. We're going to dive into the concept of a slope, or the slope of a line. And the slope of a line basically measures the steepness and the direction that the line is going. Specifically, we say the slope of a line, which is often denoted with the letter M, is the rise of the line over the run over the line, where the rise represents a vertical change and the run represents a horizontal change. Slopes can be positive numbers, negative numbers, zero, or undefined. And let me try to describe what I mean about the rise over the run of a line and how we find slope. I just wrote an example and I'm going to find the slope of this line. To find the slope of any line, you just need to know 2 points. And if you can find 2 points on that line, doesn't matter which points, pick a point that's furthest left, pick a point that's furthest right, and describe how to get from the left point to the right point using vertical moves, which are rises, and horizontal moves, which are runs. So for this particular line, if I want to describe how to get from the point 3,3 to the point 6,5 using first a vertical move and then a horizontal move, I'm going to be able to calculate what the slope of this line is. The rise is the vertical direction. The run is the horizontal direction. In this particular problem, if I start at the point 3,3, make a vertical move, which is going to be up 2 units, and then a horizontal move, which is over 1, 2, 3 units, I can know what the rise and the run is to get from one point, my point, to the next point, and I can find the slope. The rise that I've just calculated, I'm going to say is 2, because I had to get from the point 3,3 to the same height as the point 6,5. I needed to march up 2 units. And then to get over to the point, I needed to march over 3 units to the right. So I would say the run is 3. For this particular line that I drew for these 2 points, the slope, which I'll denote with the letter M, is rise over run. The rise is 2. The run is 3. Turns out it wouldn't matter if I picked this point and this point. The slope is going to be the same regardless of the points that I pick. These are unfortunate points, but let me show you that if I do a rise and then a run, I guess I went too high, but that's okay. For this, if I picked these 2 points and I wanted to find the slope, the rise is going to be 1, 2, 3, 4, 5, 6 units. So if I was going to find the slope and I picked the points that I drew on my second pick, I'd say the rise is 6 and the run's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I look at the slope from my first set of points compared to my second set of points. It doesn't look the same, but that fraction reduces. I could just take this fraction and reduce it by dividing by 3, and I'll get the same points. So it doesn't matter which points you pick. The slope that you'll calculate will reduce to the same fraction always. Let's do a few more examples to just get practiced on finding the slope of a line. So I drew another picture, or I use that graphing program that I get online, and I'm going to find the slope by just picking 2 conveniently placed points. I like, picking points that are close to each other. It makes it less steps to do this. So I pick a left point and a right point, and now I'm going to go the vertical distance, and this is going to be my rise. So my rise in my effort to find the slope of this line is going to be the number of steps it takes to get on the same vertical line. So I'm going to go down 1, down 2, down 3. I'm going to say my rise in my effort to calculate slope, which I can denote with the letter M, is negative because I stepped down as opposed to up, and it's 1, 2, 3, negative 3. The run is going to be the distance on this horizontal line, which is 1, 2, 3, 4. So it's rise over run. This is an example of a slope that has a negative line. This is an example of a line that has a negative slope. And when you have a negative, you have some freedom in terms of where you put that negative. You could have that negative in the numerator, or you could have that negative just left out to the left of the fraction. You could even put the negative in the denominator, but I'd probably leave the negative in one of the two places. A lot of times it's maybe depending what I'm going to do, but I have a tendency to write this version, but maybe I should write that version. They're both kind of equally good. The next line is a horizontal line, and if you watched the last part of the last video, I started making up some little bullet points about horizontal lines. I'm going to keep adding to that because horizontal lines and vertical lines are kind of one of these things that's not like another. In the last section, 3.1, we learned that horizontal lines have an equation in the form y equals some number. The equation doesn't have an x. The graphs cross the y-axis. They have a y-intercept. They don't cross the x-axis. I'm going to make a comment real quickly here that will apply to the slope of all horizontal lines. So let me pick 2 points and try to find the rise over run. And I might as well just pick the points that are easy for me. I'm drawn to points that are marked close to each other. So to find the slope of this line, it's a horizontal line. Turns out that all horizontal lines have the same number for the slope. And it's a little bit tricky. To get from this point to that point, there is no rise. They're on the same vertical level. So when I go to find the slope of this horizontal line, the rise is going to be 0. In fact, the rise, if I was trying to find the slope of any horizontal line, is going to be 0 because the points are on the same level horizontally. The 2 points that I drew, the point 0, 3, and that I picked, the point 0, 3, and 5, 3, the run is going to be 1, 2, 3, 4, 5. So because they're on the same vertical level, the rise is 0, and the run for the 2 points I picked is 5. It's not unfortunate or fortunate, the points that I picked. Regardless of the points that I would have picked, the rise was going to be 0 because all the points are on the same horizontal level. The run's going to be a different number depending on the points I pick, but no matter which points I picked, I'm going to get a fraction with a 0 in the numerator because the rise is 0, and any fraction with 0 in the numerator simplifies to 0. So the line that I drew has a slope of 0, and all horizontal lines have a slope of 0. Not that they were asked for it, but I should blip out some information about this. This line, because it's horizontal, has an equation that only has an x, but not a y. This line has an equation of y equal to 0. It crosses the y-axis at y equal to 3. So the y-intercept would be 0, 3. This line doesn't have an x-intercept. and it has a slope, and we usually use the letter M to represent slope. For what that's worth, that's a big deal. Lines, equations that are horizontal lines or vertical lines are, tricky when we get deeper into these sections. So knowing these kinds of facts is going to be important. It's going to make our lives easier. Lastly, before we jump into the homework, we're going to find the slope of a vertical line. I'll pick any 2 points. I like picking points that are close to each other. And I'm going to describe how to march from one point to the next using a rise, a vertical move, and then a run, a horizontal move. So my slope, M, is going to be the rise over the run. And to get from the 2 points, the first point that I picked, my rise is going to be 3. It's positive because I moved up. Once I make 3 steps up from the point 40 to the point 343, I am already at the desired point. I don't need to move left or right to get to that point, so the run is 0. And hopefully remember from the last chapter that fractions that have 0 in the denominator, we say are undefined. So the slope of this line is undefined. And it turns out that all vertical lines have slopes that are undefined. And from the sheet that I had and didn't throw out, I'm going to make some comments. So vertical lines, we learned, have an equation that has an x. They can be written as x equal to some number. The equation has an x for a vertical line. It doesn't have a y. It crosses the x-axis, so it has an x-intercept. It's parallel, and it doesn't cross the y-axis, so it doesn't have a y-intercept. And all vertical lines have the same slope. The slope of all vertical lines are undefined. So this line that I just drew, I only was asked to find the slope, but I can tell you what the equation of this line is. The equation of all vertical lines can be written as x equal to some number, and the number that makes sense for this vertical line would be x equal to 4. If I was asked to find the intercepts, this line crosses the x-axis at the point 40, so the x-intercept is 40. The graph is parallel to the y-axis, so it doesn't have a y-intercept, because that would be a point where the graph crosses the y-axis and there isn't one. And because it's a vertical line, the slopes of all vertical lines are undefined. Because to get from one point to another, you only have to do a rise. Because they're on the same vertical line, I won't have to move to the right or left. The run's always going to be 0, and the denominator, hence of the fraction, is always going to be 0. All right, so now we can jump into just the homework. It's nothing new. It asks us to find the slope of the line doing the rise over run. And let me, for problem 2, figure out what my numbers are. I don't know that this is showing up decent enough, but I'm going to try. Turns out that there's a way to find the slope by using a formula, but I'm going to pretend I don't know that formula just yet until we get a little bit deeper in this. So I'm going to find the slope of this. I'm going to say the slope M is the rise over the run. It just didn't show up well enough, the little tick marks here. So I'm going to just do my marching. So to start at the left point that's marked and march my way to the right point, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So my rise is going to be positive 8. And then my run is going to be 1, 2. My run is going to be 2. And so my slope is going to be 8 over 2, which is 4. I don't know how well you can do this. You might need to open up a better version of the graph. Just the lines for the axes didn't show up real well, and I'm not sure if you can do this with the picture I have on the screen or not. You might need to pull out another picture. Let me do the same for 4. Just because I like moving from left to right, I'm going to pick the point that I drew negative 4, 8 and the point 0, 2, but you don't even need to pick the points that I marked. I just marked some points because I knew it was going to make my life easier. I'm going to figure out what the rise is. It's going to be negative because I'm going down to get from the left point to the right point. And then the run. So I'm going to have my rise over my run. My rise is going to be negative. My run is going to be positive because I'm moving right. For the rise, negative is down, positive is up. For the run, positive is right, negative would be left, but I usually always go right. So for my rise, it's going to be negative 1, 2, 3, 4, 5, 6. So my rise is going to be negative 6, and for my run, it's going to be 1, 2, 3, 4. So the slope of this is going to be negative 6/4. I'm just going to reduce that by 2. And I'm going to leave the negative in the numerator, but you have some flexibility in terms of where you put that negative. I should start getting lazy when I have horizontal and vertical lines. The line that I drew in problem 6, I marked 2 points. I don't need to do any algebra if I know how to know what the slope of a horizontal line is. But if I don't, I can recreate this every time. But I should start working on not doing algebra for horizontal lines. So to get from the 2 points, the left point that's marked to the right point that's marked, they're on the same horizontal level. So the rise is going to be 0. And my run's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So the formula would be slope is rise over run, which is 0 over 8. Any fraction with a 0 in the numerator reduces to 0. And I shouldn't have done any algebra. If I should know horizontal lines, that has a slope of 0, no algebra necessary. As a matter of fact, this line has an equation, y equal to negative 4. It has a y-intercept. It's not marked, but it crosses the axis at the point negative 4 or 0, negative 4. It crosses the y-axis at negative 4. It doesn't have an x-intercept. And it has a slope of 0. So I'm going to be lazy on number 8. This is a vertical line. I should be really efficient with vertical lines. All vertical lines have slopes that are undefined. I don't need to do the algebra. I shouldn't do the algebra. So my answer for number 8, I'm going to use M to represent slope. And the slopes of all vertical lines are undefined. It's not asked for, but this line has an equation of x equal to negative 6. Vertical lines have equations that only have x's, don't have y's. It has an x-intercept, and not that it's terribly visible, but this graph crosses the x-axis at negative 6 on the x-axis, and that would be the point negative 6, 0. It's going to be important to be able to just rep that off for any vertical line, to know what the equation is, to know what the x-intercept is, to know what the slope is. It's going to be important. Let me pause and do, it's probably going to be a 3-part video because there's a new concept coming in and it would fit nicely in its own video.